Let's talk about Newton's method, which is the second of the two numerical analysis methods we're going to cover in Math 9. So the first one was the bisect method. So here's some intuition behind Newton's method. Say all you know about a function f is that f of 6 equals 10 and f prime of 6 equals 4. What would you guess if you had to guess what's a root of f of x? What's a 0 of f of x? And so here's the idea. So at x equals 6, I'm at height 10 and slope 4. Okay, so I'm drawing this little line here of slope 4. And well, I don't know anything else about f, and it might not have a root. Maybe f goes down like this and then shoots back up and never crosses the x-axis. But if we have to guess what a root would be, there's only really one reasonable guess, which is to just continue this in a straight line of slope 4 and figure out where does this straight line intersect the x-axis. Okay, and this would be my guess. Okay, this would be my guess for z. And so how do we turn that into a procedure that Newton's method is based off of? Well, what's the definition of the straight line that I drew here? So this is the tangent line. So it's the tangent line to f of x at x equals 6. And the idea behind Newton's method is draw the tangent line, find where the tangent line intersects the x-axis, and then repeat. So tangent line in general, so let me write this as a general procedure. Say you have f of x0, or let's just assume this is known. Let's not even say what it is. And say we also know f prime of x0. Then the tangent line at x0, so the tangent line to f of x, okay, this thing that I drew here, at x equals x0 is going to be the following. It's going to be y minus f of x0 equals f prime of x0 times x minus x0. And how should you think about this formula? You should think, so this is something you should learn in single variable calculus. You should think the slope is right because x only appears here and it appears next to this number here. So in this case, it would be slope 4. And the point x0 comma f of x0 is right. If I plug in x equals x0 and y equals f of x0, I get 0 equals 0. So that point really is on the tangent line. And now I want to find where does this curve, this y equals tangent line curve, where does that cross the x-axis? So I want to solve for 0 minus f of x0 equals f prime of x0. And let me distribute this times x minus f prime of x0 times x0. And so if you try solving this, what do you get? So x, okay, I'm like trying to find this value here. I have x is equal to, and let's divide both sides by f prime of x0. So I get exactly x0 plus or minus. Sorry, I'm running out of space on the board, so that's why I'm doing this all in one step. So when you solve this equality for x, what you get is x0 minus f of x0 divided by f prime of x0. And so how does Newton's method work? With Newton's method, you start with a guess, like in this case, you're starting with the guess 6, or in this case, you're starting with the guess x0. So x0, okay, this is like my initial guess. And then this is a recursive procedure. So given xn, okay, so that's my hopefully better guess, but no guarantee it's better. It's not like the bisect method where the guesses get better and better necessarily. So given xn, then you set xn plus 1. Okay, so this is why it's a recursive procedure, because xn plus 1 is going to be defined in terms of xn. This is going to be exact formula here, just with xn in place of x0. So it's xn minus f of xn divided by f prime of xn. And I think one of the hardest parts about memorizing this formula is where does f prime go? Does it go in the numerator or does it go in the denominator? And here's one easy way to remember that. So imagine my curve has a horizontal tangent line. Okay, then this tangent line never is going to cross the x-axis. It's parallel to the x-axis. And so Newton's method is not going to work in that case. So we want to get an error in that case. Well, what's f prime of x0 in this case? F prime of x0 is 0. And so I want to get an error, so that 0 should be going in the denominator. So that's the way that I remember that f prime goes in the denominator. I think the procedure doesn't work if I have a horizontal tangent line, and this formula doesn't work if I have f prime in the denominator, because then I'm trying to divide by 0.